differentiation of trigonometric function, product rule, and as well as quotient rule. Now, as we have already discussed that in the algebraic function that there are some direct formula we can use to differentiate some set of differentiation depending on how the question actually look like. The same is also applicable for trigonometric function. Now we can consider, as usual, the 6 basic trigonometric values and the value of their derivative. So in mathematics, still on the basis as we have already discussed, when we have a y is equals to sine x, so whenever we have that directly, we use a y prime, which is the same thing as the y ds, we take it as cos x. So students should just keep these 6 basic trigonometric formula in mind, as it will be used directly to solve questions on that trigonometric function. Again, you have y equals to cos x. So in mathematics, the y dx, which we also call y prime, is the same thing as negative cos x. The next one we can talk about is the third one. We have if y is equals to tan x. Then when we differentiate that, y prime value, which is the y dx, is the same thing as sec square x. The fourth one you can keep in mind is when you have y is equals to cot x, then the y ds, or the differential answer to that, is negative cosec square x. The fifth one, which I think you also need to keep in mind, is y equals to cot x. If we don't cot x, we have sec x. I think that is the next one. Then y prime is equals to, this is very popular, sec x tan x. So please, and the last trigonometric value I will write for you is y is equals to cosec x. Cosec x. When you have that, the y dx for that will be equals to negative cosec x tan x. So these are the 6 trigonometric values and their values of their derivatives, which you need to keep in mind. Right now, we are not discussing about how these are actually being proved or being gotten, but the only thing we are talking about here is the derivation at the direct formula. You just need to keep in mind to avoid errors and mistakes. So students should always keep it at the back of their mind, all these 6 trigonometric values, because they are going to be applied directly in our physics section as well as our sort of basis of our mathematics section as we move forward under the topic of basis of differentiation. So we can quickly take some example to understand this concept very well so that we can move to the next one. Now the example we take here, a direct one, we can look into the first. We have if you have a direct question in which you have y is equals to tan x plus 3x squared. The examiner asks you to find the y dx. So now in this case, you can see this is a combination of algebraic function and the trigonometric function. So the y dx, which is the same thing as y prime, directly tan x is sec square x. Then from what we've learned in the previous slide, 2 times 3 is 6, 6 minus 1, this will give us 6x. I hope students understand this. Again, we can consider another one for quick understanding. So if we have y is equals to sine x plus cos x plus x to the 4th power, then the examiner asks you to find y prime. Now y prime, which is the same thing as the y dx, directly trigonometric function, sine x is cos x, cos x is negative sine x, and x to the 4th power is the same thing as 4x to the 3rd power. So these are simple things which you apply directly as you try to solve questions on what of trig functions in mathematics. So another one, we can just take the last one to understand it better. If we have y is equals to sine x plus tan x, so in this case you can say y prime will be equals to cos x plus sec square x. So students should be very careful when dealing with all these, and should always keep it in mind that knowing these 6 trigonometric values, you can directly get answer to question. I can give you one to attempt. If I give you y equals to cot x plus cosec x, find y prime. Just apply the direct formula and that will be the direct answer. So the next one we talk about, because we have a long way to go on this physics, is the one we call the product rule. Very important for students to also keep this one in mind, because the product rule is only applied whenever the function of a given function is given in product form. So this is just the basic thing you have to keep in mind. Whenever the function given in the question or by the examiner is in product form, directly we apply the product rule. So we can take a very quick example where we have y is equals to uv. Now in this case, you can see u and v are function of x, because the same function is y equals to f of x. So in this case, uv's are functions of x. The application we use to do something like this, whenever we have functions that are expressed in product of another function, independent variables are in form of product. What you do directly is that to get y prime, which we call the YDS, the logic we apply in mathematics we call the product rule is that we take the first function, which is u, we differentiate the other function we call the v dx, then we add it to take the second function we call v, you differentiate the first function, you call that the u dx. This is the method that is applied to find questions in which the functions are expressed in product of the other words. We have two products as the functions of x. So whenever you are coming across a situation like this, what you are expected to use, my dear student, is to make sure that you take the first function, differentiate the other, then add it to taking the other function, differentiate the first. This is the way you are going to carefully get the answer to questions of this nature. So you don't need to have any fear when you have products that is what being expressed together. Examples, we can take some good example. We can take the first example. You were given y is equals to, we have x squared, then we have a sine x. Now, as you can see here directly, this first function, which is algebra function, is u. It is expressed as a product of another function v, which is sine x. So when you have this type of situation, the examiner asks you to find the y dx. This type of question, we apply directly what we call the product rule. Now from the product rule, to get the y dx, which is y prime, the logic is very simple. You don't need to start cramming formula. Take the first one, that is x squared, differentiate the other thing here is, when you differentiate sine x, I am going to have cos x. I will add it to take the second one is sine x, differentiate the first one, x squared is an algebra form, which is going to give me 2x. This is the answer to the y ds to that. We can take up another example to understand this very carefully. Looking at this, if we have another one, y is equals to x to the fourth power plus 7x to the power of 5, then we have tan x. The question is, find the y dx. As we've already studied that whenever we have a product of a function expressed in product form, as you can see, algebra function is x raised to the power 4 plus 7x raised to the power 5. Tan x is trigonometric function and they are expressed in product. We apply the product rule, to make sure we get the answer directly. So the y ds we call y prime will now be equals to, we take the first function, which is x to the fourth power plus 7x to the fifth power. We differentiate the other one. When you differentiate tan x, you're going to have sec square x. You are now adding it to taking the second function. The second function is tan x. You take tan x, you differentiate the first one. Differentiating this using our logic of s raised to power n. We're going to have 4x to the third power plus 5 times 7 is 35x to the fourth power, which will be the question answer. So guys, I don't think you should have issues when doing questions on product rule. We can take on one example to understand carefully what we are dealing with. Here, let's take this last example. We have y is equals to x raised to power 5 plus x raised to power 2 in brackets. Then we also have 5x raised to power 2 plus 3x plus 4. The examiner asks you to find y prime. So here also you can see that the two products are expressed in terms of algebraic form. So I just intentionally want to do these two because you can actually apply the product rule to get this, because the functions here are given in form of product. So the logic is to get y prime has already been discussed. We said we take the first x to the fifth power plus x squared. We differentiate the second one. This is 10x from our logic plus 3. Then we add it to taking the second function. This is 5x squared plus 3x plus 4. We now going to differentiate the first one, which is going to give us 5x to the fourth power plus 2x, which will be the question answer. And that is the way we apply product rule to solve directly and get answers to questions. The next one we are going to talk now in this slide is the quotient rule. And to carefully analyze quotient rule, we also follow the same principle, but in this case, we are going to express function in terms of division. Now to carefully analyze that, let us move a little bit up and understand the concept very well. Now, in physics, quotient rule and mathematics as well is also very, very important as we move forward in our concept of physics. Now, the quotient rule, as we already discussed, is used in a situation whereby the functions of what we have are two functions of x, just like the other one, but they are expressed in ratios or in fractions. So example, if we have y is equals to u over v, in this case to u and v are functions of x. They are functions of x. So whenever you have something in quotient form here or in form of division or ratio, the method we apply to get y prime is also very direct. What we do is like we take the square of the denominator, then we take the value of denominator the way it is, we differentiate the denominator, the numerator, the u, the x, we subtract it by taking the value of the numerator, which is u, the way it is, when then we differentiate the denominator, we have the vdx. So what we do to get the y dx when we talk about quotient is we take the square of the denominator, we divide, then we take the denominator the way it were, we take the derivative of u, which is the u dx, we subtract it by taking the numerator the way it were, then differentiate the denominator, it's the v dx. So all this clumsy formula, you don't need to just keep it, you just need to just keep it in mind so that you don't fall a victim of mistake. Now examples to carefully understand the concept very well. We can take in some example as usual. The first one I will discuss here is, maybe we are given a simple question of y is equals to tan x divided by x squared. We have to find the y dx. Now doing this question mark, directly we can see that the function of x, y is always f of x. The function of x is expressed as in form of quotient or ratio. So you apply the direct rule, which is what we call the quotient rule, by saying the y prime in this function is just, you take the square of the denominator. The denominator here is x squared. Square of x squared is x to the fourth power. I hope students are following. Then you now go by saying take the denominator the way it were, x squared differentiate the numerator. When we differentiate tan x, everybody knows that when we take tan x is going to give us nothing but sec square x, direct trigonometric function. We subtract it by the second one, take the numerator the way it were, tan x, then differentiate the denominator. When we differentiate x squared, we're going to have 2x. So this is the correct answer to that question, and that is the way we do this in mathematics. Then we can take up one example to carefully analyze this, which will be the last example for this slide. I can say, if we have y is equals to 1 over sine x, as you can see in your trigonometry, 1 over sine s is nothing but cosec x. Now we have to differentiate this. As you can see, the function of x are expressed in ratio. So what we do is just the same process. You take the rule, you square the denominator, this is sine square x, then you apply the law, take the denominator the way it were, that is sine x, differentiate the numerator. When you differentiate a constant, everybody knows it is 0. Subtract from, take the numerator, that is 1, differentiate the denominator. When you differentiate sine x, everybody knows it's going to give cos x. So completing this, we can say the question asks for y prime, and y prime value is nothing but, from here is 0, 0 multiplied by anything is 0, minus 1 times cos s is nothing but cos x, everything divided by sine square x. And lastly here, as I said, 0 minus cos s is negative cos x divided by sine square x. Now if you stop here, in theoretical question you are not correct. So you can simplify this from your trigonometric knowledge as this is the same thing as saying negative cos x sine square x is the same thing as saying sine x times 1 over sine x. As you can see here, my dear student, sine x times sine x is sine square x. This times this is nothing but that. So here, final answer, we can write like cos x divided by sine x is negative cot x, and 1 over sine x is cosec x. If you remember, my dear student, direct trigonometric value we give for cosec x when we started this trigonometric function at the beginning of the class was negative cos x, negative cosec x cot x, which is very correct for direct formula, as 1 over sine x is the same thing as cosec x. So student, this is where we are going to stop this slide. We move again to the third aspect of basis of differentiation, as we try to give some important tips we need in physics, so that as we continue with physics concepts, we are going to understand the aspect of differentiation as well as integration. So see you guys soon. Thank you and bye.